Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, do you want a cookie? Here you go. And welcome to Pre-Algebra. Today we're going to be talking about subtracting whole numbers. So subtraction is the opposite operation in mathematics than division. Division was the combination of groups together, and as we're going to see, subtraction is almost the cutting out of one group from another. So it's the taking away or making one group lesser by a certain value. Once you get to algebra, because it's pre-algebra leading up to algebra 1, when we get to algebra you're going to see how we can add or subtract values from either sides of an equation, and we can balance the equation by doing its opposite magnitude, opposite operations with the same magnitude. So like 3 minus 3 will nullify into 0, it'll cancel out. 10 minus 10, that's the same thing. It's something minus itself. That's called the inverse property of addition. Anything minus itself will always be equal to 0. So let me go ahead and share my screen with you. And let me get my colors. I think it's this one. And just a reminder, this is a live stream, so sometimes it gets a little bit busy during this time of day, and the iPad might be a little bit delayed from the audio, but I always try and keep an eye on the broadcast and make sure everything lines up as best as I possibly can make it, but I appreciate your understanding. So the overarching theme here, subtraction is the opposite operation of addition. Where addition represents the combination of groups, subtraction represents the reduction of one group by the size of another group. So for example, oops, I didn't want that. I want an actual pen. So for example, with addition, we're adding two groups together. So you could maybe think of it as like 3 things, 3 objects, plus 4 objects will result in 7 objects, right? Because we're grouping them together. And these values don't really have any relationship to each other. This 3 and this 4 are completely distinct. We're just clustering them together. We're combining them all at once into one group. In contrast to that, subtraction is the taking away of one value from another. So if we had 7 values, there's 7 units of something, like 7 apples, and if we take away 3 apples, I'm going to chunk that out. So minus 3 apples, that's going to give us or result in 4 apples. And actually, let me do that in another color, because that's the same value as these 4 that are remaining over here. So if you think about it as one chunking away from another, if you have a whole group, a whole value or a whole cluster of units, then if you chunk out a value, that's the same thing as subtracting it out, and what you remain with, or what you're left with, is the result, is what's called the difference between the two values. So addition has answers that are referred to as sums. So the sum of 2 values implies addition, whereas with subtraction, the magic word is difference. And you're going to see these values or these words again and again in math. If you have any questions at all, please let me know. You can either put them in the live chat function or you can drop them in the comments below. Otherwise, let's look at a few examples. So we have number 1, 6 minus 4, number 2, 9 minus 3, and number 3, 4 minus 2, and number 4 says 7 minus 4. So I'm going to solve number 1 with you, and then I'll give you some time to look at 2, 3, and 4. First of all, in math, we usually want to orient these values in a vertical fashion rather than horizontal. So if we change this to 6 minus 4, and with one-digit values, it doesn't seem so clear as to why we want to do that, but once we get into the 2, 3, 4, 5, 6, 7, 8, 9-digit numbers, you'll see how it's really helpful to orient the problem or to write the problem in this way. So if we have 6 values and we take away 4, if we have 6 units and we take away 4, so if we have 6 values and we take away 4 of them, then we're chunking out this 4, we're chunking out that 4, and so we're remaining with only 2 after the entire operation. So 6 minus 4 is going to be equal to 2. Right, I'm going to give you 3 minutes. Please look at 2, 3, and 4, and I'll keep track of time in the upper right-hand corner, and I'll update it every minute. Okay, so for number 2, 9 minus 3. So if we represent it in a vertical fashion, excuse me, we have 9 minus 3. So if we have 9 units and we take away 3 of them, so notice these 3 units right here we could represent as these values, any of these 9 values. Any 3 of these 9 values we could highlight. And the difference between them would be the result. So we'd have 1, 2, 3, 4, 5, 6 left over. So 9 minus 3 is going to be 6. So the answer to number 2 is 6. For number 3, 4 minus 2. So 4 minus 2, if we have 4 units and we take away 2 of them, then we're left with 2. 2 plus 2 is 4, so 4 minus 2 is 2. Number 4, 7 minus 4. So if we have 7 units and we subtract away 4 of them, we're going to be left with 3. Because if we chunk off 4, then we'll only have 3 remaining. So the difference between 9 and 3 is 6. The difference between 4 and 2 is 2. And the difference between 7 and 4 is 3. If you have any questions, then please let me know. I'm going to give you 2 minutes. I'd like you to look at 5, 6, 7, and 8, please. Okay, so number 5 is 5 minus 2. So if we have 5 and we take away 2, we're going to end up with 3. 5 minus 2, or the difference between 5 and 2, is 3. 3 minus 1 is 2, or the difference between 3 and 1 is 2. Again, because if we have 3 units minus 1 unit, that's going to leave us with 2 units. 8 minus 5 will leave us with 3, and 7 minus 5, well, the difference between 7 and 5 is 2. If you have any questions, then please let me know. Otherwise, I want to look at some 2-digit values. So first we're going to look at some numbers that don't regroup, and then we're going to talk about regrouping or borrowing in order to subtract values that can't be subtracted as they're written. So here, I'll solve number 1 with you. 28 minus 12. We just go digit by digit. So looking at the ones units, we have 8 minus 2. 8 take away 2 is 6. In the tens digits, we have 2 take away 1. 2 minus 1 is 1. So the answer here is going to be 16. I'll give you 3 minutes. Please look at 2, 3, and 4. Okay, so number 2, 36 minus 14. So if we represent this vertically, 36 minus 14, going digit by digit, we have 6 take away 4, that's going to leave a result of 2. 3 take away 1, that's also going to leave a result of 2. So 36 minus 14 is 22. For number 3, I'll do this guy over here. If we have 57 minus 37, in the ones digits, we have 7 minus 7. That's something minus itself. That's going to result in 0. If you have something and you take away all of that something, you're going to have nothing remaining. So 0 represents nothing. 5 minus 3 is 2. So our answer here is going to be 20. And number 4, we have 89 minus 53. 9 minus 3 is 6. 8 minus 5 is 3. So our answer here is 36. If you have any questions, then please let me know. Now I want to look at some problems that involve regrouping. And with subtraction, sometimes we refer to regrouping as borrowing. So this is going to occur when within one of the digits values, when you're taking the actual subtraction of individual digit values, the top value is not larger than the smaller value, and you can't take a larger value from a smaller one without producing a negative. But that doesn't make sense because the value overall could be larger. The top value could overall be larger just having individual smaller digit values. So for example, 111 or 111 has digits of 1, 1, and 1 in the hundreds, tens, and ones value. So if you subtract away a number like 89, 89 is smaller than 111, even though it has larger digit values, because 89 is a 2-digit value and 111 is a 3-digit value. So because it has that extra digits place, you're in the hundreds, and so it necessarily is larger. So it is a little bit counterintuitive or can be a little confusing, but the values themselves, the individual digits in the decimal holder, in the decimal values, I should say in the value place markers, they can be smaller as long as the overall value is larger because it has a higher greatest digit, leading digit. There can also, it's completely valid to have a negative answer, but we're going to get more into that in later videos. Right now we're just talking about whole numbers, which are all positive. So we're going to just be talking about positive results, but it is possible to have negative values too. There's nothing wrong with that. But let's look at number 5 together. So we're going to have 25 minus 18. So notice the problem here. When we try to subtract the ones digits, 5 minus 8, you can't take 8 away from 5 and still have a positive result because 5 is less than 8. So what we have to do is we need to borrow some from the tens digit. So I'm going to subtract 1 from the tens value. 2 minus 1 is 1. So I'm going to take one of the tens away. But remember, that 1 represents 10 ones. So the value of 1 in the tens mark, or in the tens place, has a value of 10 1 units, or a value of 10 in the ones place. So what you can do is you can sneak a little 1 in front of the ones digit and consider, instead of considering the ones digit the 5, or considering it to be 5, you can consider it to be 15. And now it's doable, because 15 minus 8 is 7. And that leaves you with a 1-digit value for your ones digit in the answer. And 1 minus 1 is 0, so we're not going to write anything. 25 minus 18 is 7. If you think about it on a number line, if you start at 0, if you go up to 25, and if you take away 7, you'll end at 18. Okay, so I'm going to give you 3 minutes. Please look at 6, 7, and 8. Okay, so number 6, we have 42 minus 25. When we try and subtract 5 from 2, we can't because 2 is smaller than 5. So we're going to borrow 1 from 4, so the 4 is going to become a 3. The 2 is going to become a 12 because you're going to sneak a 1 in front of that 2. Now, 12 minus 5 is 7. And 2 minus 3 is 1. So 42 minus 25 is going to be 17. So the answer to number 6 is 17. And I'll do this guy over here. 65 minus 37. So again, we can't take 7 away from 5, so I'm going to borrow 1 from 6. That's going to become 5, and the 5 in the 1's place will become 15. 15 minus 7 is 8. 5 minus 3 is 2. So the answer to number 7 is going to be 28. And number 8, we have 93 minus 68. I can't subtract 8 from 3, so I'm going to borrow 1 from 9. 9 is going to turn into 8. 3 will turn into 13. 13 minus 8 is going to be 5. 8 minus 6 is 2. So our answer to number 8 is going to be 25. If you have any questions at all, then please let me know. So now we're going to look at 3, 4, 5, and 6-digit values. It's still the same exact thing. It's just now you have more than 2 digits to consider. But if you ever run into a situation where you can't subtract from the top value because the top value is smaller than the larger value that you're, bottom value that you're trying to subtract by, then you just borrow or regroup from the next larger digit to the left. Okay, so I'm going to give you 3 minutes, but I'm going to start after a minute and a half, halfway through the time. I'll start solving them as well, so you can see if you're stuck at all, you can get a little bit of a head start. So 3 minutes, and I'll keep track of the time in the upper right-hand corner. Okay, so I started to solve these values. 584 minus 243. 4 minus 3 is 1. Let me get my highlighter out. So notice 4 minus 3 is 1. 8 minus 4 is 4. 5 minus 2 is 3. So that leaves us with 341. For number 2, 4 minus 3 is 1. 3 minus 1 is 2. 5 minus 2 is 3. And 7 minus 4 is 3. So 7,534 minus 4,213 is going to give us 3,321. For number 3, subtracting straight down, 5 minus 2 is 3. 8 minus 3 is 6. 8 minus 6 is 2. 2 minus 1 is 1. And 5 minus 2 is 3. So 52,895 minus 21,632 is going to give us 31,263. And lastly, number 4, again, subtracting straight down, 6 minus 5 is going to be 1. 8 minus 3 is 5. 5 minus 1 is 4. 4 minus 3 is 1. 6 minus 4 is 2. And 8 minus 4 is 4. So 864,586 minus 443,135 will result in a difference of 421,451. If you have any questions, then just let me know. Now these values, or some of these digits in these values, are going to require regrouping. I'm going to give you 3 minutes, and again, at about halfway through, I'll start solving. Okay, so number 5 asks 584 minus 296. So we're going to have some regrouping that occurs here. When we try to subtract the ones digits, 4 minus 6 we can't do because 4 is smaller, so we're going to have to borrow from that 8. That 8 becomes a 7 and the 4 becomes a 14. So now we have 14 minus 6, which will be 8. That's right here. Now, when we try to do 7 minus 9, we run into the same problem. So we're going to have to borrow 1 from the 5. The 5 becomes a 4. And then we have 17 minus 9. That's going to result in 8 as well. And then we have 4 minus 2. That gives us 2. So we have an overall answer. Oops. We have an overall answer of 288. Sorry, I moved that a little bit. For number 6, 7,534 minus 3,756. Again, we're going to have some regrouping because 4 minus 6 we can't do. So we borrow 1 from the 3. And that becomes 14 minus 6, which is 8. Borrow 1 again because we can't do 2 minus 5. So borrow 1 from the 5, that becomes 4. And the 2 becomes 12. So then we have 12 minus 5. Whoops, I'm sorry. I'm moving that there. Move that back. So then we have 12 minus 5, which will be 7. That 4, we're not going to be able to subtract a 7 away from, so we regroup again in the thousands digits. So that 7 in the thousands becomes 6, and the 4 becomes a 14. So then we have 14 minus 4, 14 minus 7, which is 7. And then lastly, we have the thousands digits, which is going to be 6 minus 3, which will give us 3. So 7,534 minus 3,756 will result in a difference of 3,778. For number 7, 52,895 minus 23,497. We write them vertically, and then when we have 5 minus 7, we're not going to be able to do that directly. So I need to borrow from 9. The 9 will become an 8. The 5 becomes a 15. And so 15 minus 7 is going to result in 8. Now when we try to do 8 minus 9, we're not going to be able to do that either. So we have to borrow from the 8 in the hundreds place. That 8 will become 7, and the 8 turns into 18. 18 minus 9 is 9. 7 minus 4 is 3. Notice we didn't have to regroup in the hundreds because the top value was larger than the bottom. Now when we try to subtract 3 from 2, we're not going to be able to do that, so we need to regroup this guy to 4, and the 2 becomes a 12. 12 minus 3 is 9. 4 minus 2 is 2. So 52,895 minus 23,497 is 29,398. So 29,398. Number 8, 864,586 minus 686,198. If we write that in a vertical orientation, when we subtract 6 from 8, we're not going to be able to do that, so we need to regroup. That's going to turn into 16 minus 8, which is 8. When we try to subtract 9 from 7, we can't do that either, so we need to regroup again. So the 5 in the hundreds place will turn into a 4, and the 7 in the tens place that we regrouped from before will turn into a 17. 17 minus 9 is 8. We don't need to regroup with the hundreds place because 4 minus 1 is 3. When we try to subtract 6 from 4, we can't do that, so we need to regroup. So the 10,000s place, the 6 in the 10,000s place is going to turn into a 5, and the 4 in the thousands place will turn into a 14. So then 14 minus 6 is 8. When we try to subtract 8 from 5, we're not going to be able to do that, so once again we have to regroup. So the 8 in the 100,000ths place will turn into a 7. This 5 that was regrouped in the 10,000ths place will now turn into a 15. 15 minus 8 is 7. And finally, 7 minus 6 is 1. So 864,586 minus 686,198 has a difference, or results in a difference, of 178,388. I'm sorry, let me write that over here. If you have any questions, then please, please, please let me know. But that's going to bring us up to the end of class today. Let me bring my screen back. On Friday, we'll continue this work with numbers larger. We'll do a quick review of 1 through 6-digit values, and then we're going to be working up in through the millions, the 1 millions, 10 millions, and 100 millions, all the way up to 1 billion. But again, I'm Mr. Matt, and this was Dr. Todd. Dr. Todd, would you like a cookie? Dr. Todd gets a cookie for saying goodbye to everybody after each lesson. Come on, you want to say goodbye to everybody? You guys say goodbye. Come on. You give a paw, say bye. Yeah, he's very excited to get his cookie. Very good job. All right, thank you guys very much for watching. If you have any questions, then please drop a comment below. If you found this video helpful, please like the stream and subscribe to my channel. I'm here for you guys every day. The Pre-Algebra Academic Support Program streams Monday, Wednesday, and Friday from 5 o'clock to 5:45. And after that is Algebra 1, Geometry, and then Algebra 2. Remember that Tuesdays are reading days and Thursdays are writing days. For a full schedule, you can check out my Facebook page and respond with any questions or recommendations that you have on any of my social media platforms. All right, thank you guys very much. I hope you have a great day.